Hello, everybody. My name is Mitch Etchason. I'm a product manager with Scale Computing, and I'm here today to talk about expanding to the edge, next generation IT infrastructure. Thanks for joining. So let me go ahead and share my screen here. All right, so to start us out, let's go ahead and set the stage for the presentation. So as we all know here today, every part of business is now tied to technology, whether it's accessing information, automating workflows, or even developing next generation innovative customer experiences. Every aspect of the business process and processes are now directly related to critical applications, and those applications need to run somewhere. So the fact that this rapid digitalization of technology has become the norm over the last few years or so means that the IT infrastructure that is supporting these business applications is incredibly crucial. Um, Over the last decade and then some, we saw the rapid expansion of cloud computing. And cloud computing was really great and ushered in this era of digital innovation by allowing IT teams to not have to be the full owners and managers of their entire IT infrastructure. It also allowed for easier availability and scalability. I think of software as a service applications that are much easier to expand and much more flexible as the capacity requirements rapidly change due to usage changes. And that is those are all really great use cases for cloud computing, and that's why cloud kind of continue to usher in this era of digital innovation where every aspect of business is tied to technology. However, what we've seen over the last few years in the industry is a recognition rather that cloud computing is not ideal for every single application. It is great for those reasons that I just mentioned, and did a great job expanding new technologies into the business field. However, what I'm displaying on the screen now are 5 primary factors and reasons why cloud is not ideal for every type of business application. So the first is pretty self-explanatory, and that is cost. Cloud can be very expensive, particularly as the amounts of data needed to be hosted in the cloud grow, which brings me directly to the next factor, data explosion. I think of things like next generation computer vision and AI powered video applications or video surveillance applications that generate terabytes and terabytes and thousands of terabytes of data. When hosting all of that information on the cloud, it can quickly be cost prohibitive. And we've actually seen over the last few months and years, even cases of repatriation from the cloud back to on-premises computing for that reason. Another really critical reason where cloud computing does not make sense for every application is when applications require ultra low latency. There are a few examples that come to mind. One would be when a application is making use of real-time data being collected from sensors on a factory floor. It also could be more customer-facing experiential applications, say a customer experience interactive mirror display in a store where the IT team deploying that experience wants ultra low lag for a better customer experience. Another great example of cloud not being sufficient would be when resiliency is critical, but internet connectivity is not assured. Scale computing has a lot of maritime customers, for example, where you have vessels that need to run a set of critical applications. But when out at sea, those vessels don't have a consistent or reliable internet connection, but yet they need the resiliency in their infrastructure to make sure that those applications are always being supported. And that's yet another use case where cloud is not ideal. And then finally, another main reason that cloud will not be sufficient is regulations. We see certain industries and verticals where data sovereignty is incredibly important, and an organization needs to make sure they have total ownership over every aspect of customer and user data. And once again, it can be easier when you own every single piece of your infrastructure stack to make sure that you're in regulatory compliance. And so all of those reasons just mean that while cloud is great for many, many use cases. It's not sufficient for all use cases. And that is why over the last few years, we've seen a rapid growth in the concept of edge computing. Just as a quick definition, I consider edge at a very high level when applications are hosted outside of the cloud or outside of the walls of the traditional data center. And due to the reasons that we saw on the last slide, we are seeing a rapid explosion in edge computing. That's why analysts like Gartner are forecasting that by 2025, 75% of all data will be generated and processed at the edge. And perhaps even more telling than that factor is that data is moving to the edge twice as fast as it moved to the cloud. And that to me is incredibly telling, because we all lived through the cloud explosion over the last few years. And to understand that we are moving data to the edge even faster than that is quite breathtaking. And it also really illuminates the fact that organizations are going to need a next generation edge specific IT infrastructure to support those new applications and support that movement of data to the edge of the network. However, edge is not a new concept. We have always been running applications outside of the cloud, for example. What is new is the realization that it makes sense to support those workloads at the edge of the network long term. It makes sense that the industry is realizing that applications should run where they are most efficient, whether that is in the cloud or whether that is at the edge of the network. And often what we're seeing is organizations are developing hybrid environments where they have both cloud footprints as well as edge footprints. So if there have been applications running at the edge, what are the legacy infrastructure solutions that are supporting those? And we typically see three really common scenarios with a myriad of different challenges. The first type of edge deployment that we see supporting legacy edge applications is just deploying physical infrastructure, whether that be physical point solutions or bare metal servers with standalone applications. This is certainly not an ideal infrastructure to support robust edge use cases, mainly because you do not have high availability or redundancy built into the stack. And it's also incredibly hard to manage the physical infrastructure remotely when the vast majority of edge computing locations do not have IT staff on site. And so that really makes maintenance over the time of physical infrastructure costly and challenging. Hardware does fail. It is just an unfortunate reality of the IT industry. And so when a physical solution or an edge application does fail, that often requires an expensive truck roll to go out and fix that remote system in the field. The step up from that would be a non-redundant virtualization infrastructure. And by that, I mainly mean standalone servers running a solution like VMware and Hyper-V. To me, this is a step up from entirely physical infrastructure, because you do get benefits of virtualization for running multiple applications. However, you still lack redundancy in that stack, and those applications will still potentially be brought offline when hardware does fail. So then from a legacy perspective, if IT organizations then wanted to increase the resiliency of their virtualization infrastructure, they would often turn to a traditional 2-to-1 or 3-to-1 virtualization strategy. And by that, I mean a virtualized environment running Hyper-V or VMware and using maybe 2 or 3 hosts, a couple of switches, and shared storage. And while this is by far the most redundant and highly available infrastructure of these 3 legacy types of deployments, it is really essentially IT teams taking what is a data center technology and trying to cram it down and force it into an edge footprint and an edge profile. And that has several challenges in itself, because despite the redundancy, you often have multiple vendors in this total solution with multiple support contracts. So it is not giving you a single vendor to contact for support. And also, because it's multi-layered, it's very complex to maintain. And complexity does not scale adequately for an edge deployment with hundreds or even thousands of sites. And so for all of those reasons, IT organizations and distributed edge organizations are turning to next generation infrastructure platforms that do provide availability, simplicity, flexibility, and efficiency. And these are what I consider the pillars of a next generation modern IT infrastructure specifically for edge computing. Availability is necessary to ensure uptime for critical applications. As mentioned, edge locations often do not have IT resources on site. So an infrastructure that will just remain running and automatically solve issues in real time is incredibly important. Simplicity is also important because management items that may only take seemingly a few extra minutes, a few extra hours at one site, that extra time spent per site will scale and suddenly become additional hours and hours that a IT team that is likely already strapped for time will have to deal with and become an insurmountable obstacle in its own. Plus, then you have the issue of efficiency. Going back to that 3-2-1 or 2-2-1 virtualization infrastructure that I mentioned earlier, typically that is a large IT hardware infrastructure that is overkill from a capacity perspective for edge computing environments, which often only require a handful of virtual machines and applications at the small end. And so software stack efficiency is really important to making sure that the software manipulating and managing infrastructure can run on physically small devices, while also delivering flexibility in things like hardware replacements and growth. We are projecting an immense explosion of applications being deployed out on the edge. And so that means that a ideal edge infrastructure needs to be able to grow as new workloads are being deployed at the edge over the next decade or so, where, once again, per Gartner, we're seeing a projection of tremendous rapid growth in this movement of data and applications to the edge of the network. And these four pillars of a modern self-healing infrastructure are what we at Scale Computing deliver with the Scale Computing platform. I always like to quote our Chief Product Officer, Scott Loftmiller, when it comes to how simple we want to make the management experience for a large distributed edge organization. Scott always says that if you are an edge organization with 1,000 sites, we are building and have built the platform to make managing that deployment of 1,000 sites feel like one deployment, not 1,000 deployments. And that really speaks to the design ethos of Scale Computing. Our motto is simplicity engineered. And that is what we are delivering for the edge infrastructure for distributed edge organizations. We are essentially giving a cloud-like management experience, but for applications that are running at the edge of the network outside of the traditional cloud. But when I say the Scale Computing platform, that's a little nebulous. So what do I actually mean specifically? The Scale Computing platform is comprised of three primary factors, three primary pieces. The first and the foundation of the platform is HyperCore. HyperCore is our edge-focused, hyper-converged infrastructure platform that combines software for virtualization, compute, storage, and backup and DR functionality into a single turnkey appliance that is fully integrated and easily deployed at edge locations. This is software that runs on premises on physical hardware at the edge locations themselves. You can essentially think of it as an elastic, self-sustaining private cloud at hundreds or thousands of remote locations that require applications run close to where the actual business is happening. The second component of the Scale Computing platform is our hardware. This is an entirely turnkey appliance, meaning that HyperCore comes pre-imaged on physical hardware devices that are deployed at customer sites after being purchased from Scale Computing. And that has a few primary benefits. Namely, it means that we handle every component of our stack from the hardware up through the virtualization technology. And it also means we're able to facilitate the hardware warranty for our customers and on the behalf of our customers, rather, for our hardware vendors like Dell and Lenovo and Intel. And once again, that makes an incredibly supportable and turnkey platform where you have a single vendor that is covering every component of the stack. And it also means that there's not going to be any finger pointing. Those legacy solutions that I mentioned a few slides ago often involve several different vendors, and it is very easy for end users to get caught up in finger pointing among vendors when there are software issues. And that is not a problem when our platform involves HyperCore being directly integrated on hardware being sold by Scale Computing as well. The third and newest addition to the Scale Computing platform is Fleet Manager. And this is arguably the most exciting introduction that the company has made in the last few years. Fleet Manager is our cloud-based centralized management system for an entire fleet of HyperCore deployments. It allows a single cloud-based pane of glass for monitoring alerts and conditions across your fleet. It allows for one-click rolling updates to be remotely kicked off. It also allows IT organizations to easily drill down into specific VMs and clusters for individual location management. Additionally, it also facilitates a brand new technology called zero-touch provisioning that allows for remote installation of HyperCore clusters at the edge. And I will speak about zero-touch provisioning in quite a bit more detail here in the next few slides. But first, let me speak a little bit more specifically about HyperCore. So as mentioned, this is our foundation for supporting applications at the edge. It is entirely hyper-converged, meaning it combines all the necessary components for virtualization in one single stack, while also serving up persistent, highly available storage paired with an AI ops management system that can detect and remediate hardware issues in real time. There are a few specific components of HyperCore that I would like to call out real quick, namely AIM and Scribe. AIM is that AI ops engine that I just mentioned. It is our proprietary state machine technology that allows HyperCore to proactively recognize issues in both software and hardware, and then take the necessary steps to automatically recover and solve those issues in real time, thus ensuring uptime for customers. Scribe, on the other hand, is our proprietary storage architecture. It is a block engine that provides full high availability across a cluster of several nodes, providing things like live migration, rolling updates, and then, of course, resiliency in the face of hardware failure, like a hard drive failing or a node failing. Those two pieces combined with our proprietary KVM-based architecture mean that this really is a turnkey all-in-one experience that operates as a redundant elastic private cloud outside of a traditional data center at the edge of the network where applications need to be hosted. We handle hardware failures gracefully, as mentioned, but we also handle hardware expansion gracefully, meaning that if you say start with a 3-node highly available cluster, you can simply add nodes to that cluster as time goes on. If you need to expand the compute and storage footprint at all of your edge locations to satisfy new digital innovation or new applications needing to be deployed at each location. We put a huge premium on redundancy and availability, as well as simplicity. HyperCore has been released for a little over 10 years now, and we've seen wide adoption and success in the market, mainly because, once again, our motto is simplicity engineered, and IT teams have really been drawn to how simple our solution is. And it's basically the design ethos of HyperCore to make a complex problem in a virtualization platform be solved in a package as easy to learn and manage as a smartphone. That saves IT teams time and allows them to focus on other management tasks. In addition to the availability, simplicity, and simplicity, another one of our core design priorities is efficiency. Scribe does not rely on the legacy traditional virtual storage appliance model to provide highly available storage to our hypercore clusters. Not relying on this VSA model means that we can cut out on a few IO hops in our stack, as well as we can run on physically smaller infrastructure than other solutions, because it takes very minimum RAM and compute resources just to run our operating system. And that is why we fully support and ship on platforms as small as the Intel NUC today. The Intel NUC is the basis of our HE150 and HE151 platforms. As mentioned, Hypercore has been seeing success in the wild for about 10 years now. And it's been deployed at thousands of customer sites. And we largely see that once a Hypercore cluster has been installed and the applications deployed onto it, it is pretty much smooth sailing, because AIM and Scribe give such redundancy to the actual infrastructure and applications running on that infrastructure. So over the last few months, we on the product team really took a step back and developed this concept of the infrastructure management lifecycle with day 0, day 1, and day 2. Day 2 and beyond really relate to that ongoing application maintenance that I mentioned, that once clusters are deployed, it's largely trivial to maintain Hypercore infrastructure remotely because it's so self-sufficient. So we on the product team then said there are a lot of opportunities to improve the issues around site and cluster deployment, which we call the day 0 problems, and then application migration and deployment, which we call the day 1 problems. And it is crucial that we speed up the ease of cluster and application deployment, because edge organizations do not have the time to spend days, weeks, or months running systems and deploying new clusters out in the field. So as early as last month, in order to solve first the day 0 issue of cluster deployment, we have released a new technology called zero-touch provisioning. Deploying a virtualization platform at the edge often looks like what I have on the left of the screen there. It is typically a long, convoluted process that can involve several IT teams or several teams within IT working together to install remote systems that then require extensive maintenance and testing. And this is not an easy, streamlined way to deploy infrastructure. And that's why, as mentioned, we've seen customers take days, weeks, or even months just to deploy single systems, which is not satisfactory when you might have hundreds or even thousands of systems that you need to deploy, because you will essentially never catch up at that speed of initial deployment before other sites have infrastructure that is end of life and need refreshed. And so we developed zero-touch provisioning to solve this problem. Zero-touch provisioning is a combination of technology from Hypercore and Fleet Manager that allows users to remotely configure the Hypercore cluster configuration in Fleet Manager before gear actually arrives on site, so that when those nodes do arrive, they will automatically reach out to Fleet Manager, pull down that configuration file, and initialize themselves. But rather than just telling you how great zero-touch provisioning is, I'm actually going to go ahead and transition to Fleet Manager now and demonstrate what this functionality actually looks like. So here on my screen is our Fleet Manager tool. Once again, this is the component of the scale computing platform that allows for easy multi-site management across a fleet of Hypercore clusters. Right now, you are seeing the Scale Computing Product Management organization. This fleet is just comprised of nodes that are owned by the product team at the company for testing. But this is exactly what it would look like for a customer that had their own fleet of Hypercore nodes. At the main dashboard here, you can see we have a condition event timeline. That is a very glanceable, high-level view into if your fleet has clusters disconnected or in a critical or warning state. So that way you can quickly identify problems and assign technical resources to solve those issues. Similarly, we also give the overall health status of your entire fleet. Obviously, you want as much to be green as possible. And then lastly, on this main dashboard here, we have a version breakdown of all of the Hypercore versions that are being run by clusters in the field. Now switching to the second tab here, this is the clusters page. So this gives a better, clearer view into every single one of the Hypercore clusters that would be deployed at an individual edge location. It gives high-level information about, once again, if the cluster is healthy, but also some more specifics around how many nodes are in the cluster, how many VMs are running, and then also the capacity utilization of the clusters themselves. I do want to point out here, next to the version info, we do have the ability to kick off one-click rolling updates directly from Fleet Manager. And it is, once again, a rolling update. So if we look at this node right here that has 4 nodes, if I were to click off this update, it would automatically start live migrating virtual machines among the 4 nodes in those cluster as nodes need to reboot for the software update to apply, which eliminates downtime. Lastly, we have just a nodes list. So one important thing to call out before we turn to the zero-touch provisioning demo is we have a very tight integration between our internal business systems and Fleet Manager. And so that means that customers that purchase nodes from Scale Computing and also are using Fleet Manager will automatically have new nodes included in their Fleet Manager portal when those nodes ship. When that automation happens, let's say, for the sake of this demo, I am going to deploy a single node Hypercore system at a brand new store. When that node would ship, I would find that node in the nodes view here with its hardware serial number. And its hardware serial number is what actually does the linking for zero-touch provisioning. So I do want to call out that all nodes in your fleet, all pieces of all assets from Scale Computing show up in this node view. And that includes both nodes that have been provisioned into a cluster, as well as nodes that are unprovisioned right here. So let's go ahead and use zero-touch provisioning to install a Hypercore cluster as a single node system for a new location. First, you go to add cluster, and let's give this cluster a name. Let's say I'm deploying a new store. Store 412. Let's give it a LAN net mask. LAN gateway. And then notice that we already have filled in information where we can. I will leave the backplane net mask and backplane VLAN ID alone for simplicity's sake, but we try to autofill where we can to make it as easy as possible. So this is the overall information for the scale cluster. And now I'm going to add the specific nodes that I want to join that cluster here. Notice all of my unprovisioned nodes show up in this view, but I happen to know that I care about this node right here. And I'm going to add this node to the cluster. Note I'm only doing a single node cluster today, but if you're going to do, say, a 3-node cluster, you would simply add your 2 other nodes here. I do want to call out, for simplicity's sake, I have this physical HE150 node already plugged in to networking and powered on in my lab. I'm only doing that so I don't have to run away and go powered on. That is not a requirement for zero-touch provisioning, though. You can specify your cluster configuration information before nodes even arrive to the installation site. And then once those nodes are connected to power, networked up, and powered on, then they will still be able to reach out and pull down their configuration information. This is, for those curious, a NUC-based system in my home lab. So let's give this single node system its IP address, backplane IP. Then I will leave the software license alone, which once again we have auto-filled. So let me go ahead and double check and make sure my configuration information is correct. Perfect. So let's go ahead and create cluster. And as you'll see, my cluster is successfully staged. So you can see here, we have two tabs, deployed clusters and staged clusters. For store 412 is the new site that I'm remotely installing. And you will see that the nodes have began initializing. This is an automatic process now, but it does take about 10 minutes. So we will return to the presentation while we wait for the node to finish initializing. All right, so that was a brief introduction to Fleet Manager and demonstration of zero-touch provisioning. Zero-touch provisioning is our solution for the day zero problems around cluster initialization. But as mentioned, we also have been spending a lot of time and effort into developing for those day one issues around application deployment. The first and most powerful solution that we've recently brought to market is our scale computing hypercore Ansible collection. For those who don't know, Ansible is a IT automation tool built specifically for IT operators. It allows you to automate virtually every aspect of your hypercore virtual machine lifecycle, as well as do things like set cluster settings. I always say that if you find that you or your team are manually performing a routine task, it is probably a good opportunity to automate with a tool like Ansible. Through Ansible, you can do things like provision VMs, set cluster settings, manage snapshots, clone VMs. Everything that you can do around the VM lifecycle, you can pretty much do with our set of Ansible modules in the Ansible collection. My coworker, Dave Demlo, has some really powerful demonstrations with Ansible that I would encourage you to check out. As mentioned, Ansible is designed for IT operators, and that has a few really key benefits for deploying IT infrastructure at the edge. Namely, it's a small learning curve. One does not need to know how to code to become proficient in Ansible. And part of that is because the scripts, or playbooks as they're known in Ansible, are human-readable YAML files. So it's very easy to start with our collection examples and start editing to very quickly come up with fully fledged scripts that can get really high touch and do a lot of really advanced automation. Some other important benefits of Ansible are that it is idempotent, which means that Ansible is intelligent enough to only make required changes in a playbook. So what that means is, let's say I have a playbook where I want to deploy a point of sale application at every one of my remote locations. When I go ahead and run that playbook against my inventory of hypercore clusters, when going through that playbook, Ansible will be able to recognize if that point of sale that I desire to be on the system is there. And if it recognizes it's already there, it will skip that step in the playbook and go on with the remaining tasks. And that's really important because it essentially allows declarative state-based configuration management, which is a super useful way to manage an entire fleet of clusters, where you basically just want to say, I want my state of all my clusters to be like this. Ansible, with its idempotence, is a perfect tool to go out and ensure that you're in compliance with those desired states. Ansible is an open source tool as well, meaning it is free. However, our collection is entirely Red Hat certified, meaning that customers of the Ansible automation platform that get support from Red Hat will get support for the Hypercore collection, just like all other officially certified collections. These are a couple of screenshots. I'm not demoing Ansible today because it was a little out of scope of the presentation. However, we do have really important and really exciting demos from a recent event called Edge Field Day that I would highly recommend anyone that is interested go check out. On the left there would be an example of a Ansible playbook for those who have not seen one before, and then on the right would be an example inventory file where you can essentially stage and organize all of your hypercore clusters. I would encourage you to go watch Dave Demlo's demo, though. It really is powerful and shows how an IT team can go from using zero-touch provisioning to automatically installing applications using Ansible without any manual interference at the cluster itself. The next most important solution that we've brought to market for dealing with those day one issues of application configuration and deployment would be our REST APIs. When we launched the Ansible collection last fall, we started out very squarely focusing on allowing automation of all items of the VM lifecycle. So that means that where there is not yet currently a module or Ansible module for automation today, the REST APIs can pick up the slack. Because essentially anything that can be done in the user interface can be automated with a PowerShell or Python script alongside our REST APIs. Automation not only saves time, as mentioned, it also reduces human error. And so that's why the combination of REST APIs and Ansible are so important to speeding up both the speed at which a customer can do deployment, but also the efficiency and cutting down on issues and errors. One of the most important aspects of both the Ansible collection, though, and the REST APIs is our support for a technology called Cloud Init. So for those who don't know, Cloud Init is a Linux-based technology that essentially lets users programmatically provide a brand new Linux virtual machine with its configuration information that will be applied upon the first boot of that machine. This information is provided through a user data file. This can be provided both via the REST APIs and through Ansible, and it allows an automatic setup of things like users and groups and host name and setting up SSH. Perhaps more exciting, though, through Cloud Init, you can have a brand new Linux machine automatically run a script or individual commands to do things like, for example, run a Docker command that installs a specific container. Or in the case of Dave Demlo's demonstration, you could look at a third-party application orchestrator like IBM Edge Application Manager or Avasa, and automatically install the agent of that solution in a new Linux VM on scale, and essentially have that Linux VM respond to the application orchestrator automatically without any manual configuration needed locally. And so once again, that is just expanding the story of we are taking an uninitialized cluster from the beginning to having workloads running and even checking into application orchestrators for deployment without any manual intervention locally. As mentioned, too, tools like Avasa and IBM Edge Application Manager are incredibly important because we, like the majority of the IT industry, do see containers as the dominant next generation of application deployment. And so that means that we are making the investments and continuing to make the investments required around ensuring HyperCore can support both legacy Windows-based applications and containers. When I talk to Edge prospects and Edge customers, one of the biggest differentiators I see in our platform versus others is the fact that we can easily support Windows and containers. You often have this bifurcation in the industry where some edge-based solutions are only forward-looking and cannot support Windows, or only backwards-looking and struggle with containers. And we are unifying both of those architectures in a single platform, which means that organizations that have some legacy VMs around today can implement scale while also ensuring they've implemented an infrastructure platform that will grow as they deploy those new container-based applications. It is trivial to deploy, say, individual Docker containers in Hypercore VMs, but we also see very commonly edge organizations deploy single node Kubernetes clusters where the single Kubernetes node is a virtual machine running on Hypercore. So they still get the management benefits of Kubernetes, but can avoid the management headaches around Kubernetes clustering. And they are still providing resiliency and high availability to that application in the Kubernetes cluster because they're essentially handling that at the infrastructure layer with Scribe and Hypercore, where that single node, a Kubernetes cluster, will migrate when the VM migrates should there be a node failure. And so you're handling that with Hypercore rather than Kubernetes itself, which is a really powerful methodology. So all of these solutions around the day zero and the day one issues lead us to two places. I've talked a lot about these advancements making it possible for IT organizations to deploy scale clusters right to remote sites without needing to stage them. But in reality, most of the enterprise edge organizations that I speak with, as of right now, still like to stage their cluster deployment. And luckily, we have made sure that zero-touch provisioning, Ansible, and our REST APIs fit that staging process and speed up the deployment of staging. In this strategy, an organization would essentially have new nodes shipped from us directly to a corporate lab for staging, and they would use zero-touch provisioning to provide that new hardware with its configuration information for the lab networking environment. So that way, when the gear arrives at the staging lab, all it needs to do is unboxed and powered on. It will automatically initialize itself. Then the Ansible playbooks can take over, install the machines. Finally, they would re-IP the solution, pack it up, ship it out to the site, at which point no more configuration would be required. A resource would merely unbox the nodes, plug them in, power them on, and it's already running. And while this is great and works for a lot of organizations and is often what IT teams are expecting going into a deployment, we are attempting to make the staging process so seamless through these tools that then ultimately customers decide they don't need to stage at all. And they can cut out a few of those steps because they are now comfortable deploying infrastructure with zero-touch provisioning, Ansible, and our REST APIs that they know they can ship directly to the site, not have to stage at a corporate location, have non-technical IT staff even physically plug in the nodes, and then remotely provision the entire system with a combination of these solutions that we've brought to the market for the day zero and day one problems. So with that being said, let me go ahead and check if our store is done initializing. All right, so yep, it looks like store 412 has completed its cluster initialization successfully. Let's go back to the clusters tab. It looks like we are still initializing the final pieces of the cluster. So let me go ahead and check for questions. Looks like we don't have very many questions around the technology. I'm not in San Francisco. I'm in New York City. We got one question about the sirens go by. I apologize about the sirens. I live relatively close to a hospital, which is why there are those sirens. We do have a question, let's see, about how the solution is priced. So the platform is priced in two ways. First, there is a software license for each individual Hypercore node. and that is based on the number of physical cores being licensed in a cluster. So let's say there were 8 cores in a node, you would buy the 8-core license for that node. The reason that we price along cores is because we believe our value is most adequately conveyed and adequately consumed by the consumer based on the number of virtual machines and containers running on a system. And we think the closest proxy is the number of compute cores. Okay, so with that, let me go back to Fleet Manager. Yes, we are fully done here. I'm going to go to store 412. You can see our IP address, that 136 IP address took hold. We have the node reporting in. There's an alert because alerts have not been configured, but let's prove it. Let's go to this cluster, go to this tab. It just pulled up this tab from Fleet Manager. You can see there is a brand new cluster that I've remotely installed using zero-touch provisioning on this call. And I really don't want to understate what I did here today. I've talked with edge customers that it can take them days or weeks to set up a virtualization environment, and we are able to do it in 10 minutes on a webinar presentation. And I think that is really novel. Here you can see it is node 192.168.10136. So it did come online successfully. And at this point in the process, Ansible playbooks or Python or PowerShell scripts could take over and start doing things like importing ISO media or creating or importing virtual machines like I just did. It's just that simple. So with that, that is all of my presentation today. I believe those were all of the questions answered. So please, I encourage you to reach out to Scale Computing. We have a lot of additional demo resources, as mentioned, and we're also more than happy to always hop on the phone and talk about use cases and show you a lot more about the platform in person. I just scratched the surface with what we can actually do. And so I would encourage everyone to reach out and see more, because I believe it is that next generation infrastructure designed specifically for the edge that can solve a lot of the problems around supporting applications outside of the cloud or the traditional four walls of the data center. So with that, thank you very much.